Look at the current health and wellness market. It operates like this. Thousands of isolated clinics, treatments, and providers crashing into each other without structure. Navigating this ecosystem using traditional directories or subjective five-star review platforms fails because these systems cannot process complex biological variables. They offer static lists to dynamic bodies. Solving this requires building a digital twin, an exact multivariable data model of a user's current health baseline, logistical constraints, and biological goals. Achieving peak physical optimization, what we call the overtime body, is a problem of predictive simulation. You need a system capable of taking that unique digital twin and mapping it perfectly against a highly complex real-world health ecosystem. This is the operational purpose of Kai Genesis. Operating out of Phuket, Thailand, Kai is a fully autonomous intelligence agent built entirely for high-performance health optimization. Kai replaces manual research with a deterministic decision tree. Instead of presenting endless options, it calculates a single, mathematically optimal protocol for one specific person. But a decision tree is only as effective as the data it processes. To calculate with this level of precision, the system requires a highly dense, verified architecture of regional health data. Without a vetted baseline, an AI recommendation is simply a guess. True optimization demands synthesizing multiple, distinct layers of intelligence before running a single simulation. This knowledge model is the AI's data foundation. The first tier, public intelligence, ingests all Phuket market data, locations, logistics, literature, and regulations. The second layer maps community consensus, extracting verified outcome patterns from real-world experiences, explicitly ignoring subjective ratings and numerical scores. Crowdsourced data leaves a margin for error, requiring a verifiable anchor. That anchor is verified lived experience. This apex layer uses strictly verified physical journal data, documented outcomes from a real human body, providing undeniable proof points that test public intelligence against reality. Stacking market data, consensus patterns, and verified biological reality neutralizes marketing bias. The result is an entirely objective map of the region's wellness ecosystem. Once the market is mapped, we move to the simulation phase. This wireframe represents the personalization engine. Users define their unique digital twin by submitting current biological baselines, specific optimization targets, available timelines, and physical risk tolerances. The system then projects the health market as an infinite decision tree, representing thousands of potential treatment pathways across the ecosystem. The AI rapidly applies the user's logistical and biological constraints to the entire network. Pathways exceeding the budget, misaligning with timelines, or violating risk parameters are dynamically eliminated. Kai doesn't produce generic lists. It narrows the tree to a single, definitive protocol. True personalization requires running thousands of invisible simulations. It eliminates market noise to deliver the one statistically perfect protocol for a specific human body. The final output is a highly customized, frictionless protocol. It pre-qualifies the user and routes them directly into the systems of specialized providers. How the AI communicates this protocol is strictly controlled. As this interface shows, it operates using only two distinct voice modes. The first mode focuses on objective presentation. The AI delivers honest context regarding provider fit, allowing users to self-select the best option without subjective verdicts. The second mode surfaces considerations. If verified data indicates a genuine safety risk, the AI flags it plainly, leaving the final judgment to the user. This strict neutrality is governed by the integrity standard, which serves as the absolute foundational rule of the entire architecture. If the AI recommends a pathway based on sponsorship or financial relationships, rather than an objective biological match, the mathematical logic of the simulation collapses entirely. The system's utility depends entirely on its refusal to manipulate data. An uncompromised algorithmic match provides exponentially more value than any sponsored placement. Engineering the overtime body requires autonomous agents capable of synthesizing massive, multi-layer datasets, mapping them to individual baselines, and simulating precise treatment protocols. This flowchart illustrates the system's continuous learning mechanism, the autonomous feedback loop. Genesis operates without subscription tiers, working exclusively for user feedback. Every human outcome is immediately routed back into the knowledge model. This continuously refines the decision tree's predictive accuracy for the next user. This creates a compounding intelligence asset. It acts as a localized single source of truth, growing more accurate every time a human interacts with it. To map your own physical variables against this decision tree and engineer an optimal baseline, initiate a conversation with the intelligence agent at projectkigenesis.com.